Okay, previous class, we stopped at these slides. We talked about processing, how important is engineering material. We will study about how you process later, structures, properties, and performance. All right. Now, in this module, you deal with three types of material, metal or metallic materials, polylomic or polymer that you learn in your chemistry class. Then you go into ceramic, right? So all these things, how we differentiate them in the dimension of engineering materials, we look at how they behave, right? We look at how it behave, and as an engineering module, we like to quantify something with their properties. So what are their properties? Mechanical properties, electrical properties, and other physical properties, right? The rest you read. So important for today, you know that we will study three types of materials: metallic materials or metal, polymeric material, polymer, and ceramic material or composite. So you need to pull your understanding in the periodic table, right? So I hope you know what is this. This is periodic table. So it will be your good friend when it comes to your test 1, test 2, and final exam. Okay. So just a recap, how you read a periodic table. You read by row and column. So the first one, the first column, we call it family 1, right? Family 1, family 2, and then you read accordingly. Okay. So family 1, family 2, family 3, and then 7, and then 8. 8 family of 8 is a very stable element. Okay. So column 1, general understanding is you have an extra electron outside. Means there is a extra electron to share. Right? It can throw away 1 electron. Then continue with the rest lah. If you have 2, family 2, then 2 electron or 2 bullet to throw away, and so on. Okay. Then we will study the column later. Column means something else. It means something else. In general, the column, the row, it means how many orbit it have, right? How many orbit it have. Right. Okay. So this is a very fundamental periodic table. Okay. So just now we know that we have metallic material, polymeric materials, and ceramics. So a big family that we can separate inorganic substance into metal and non-metal, right? Okay. So metallic alloy, it means this one is element. Element means one item. When in engineering material, if you see the word alloy, alloy means you mix 2 types of material together, it become alloy. Okay, so the first one, I think you also quite familiar with this name, with this ion. Chemical name is Fe, or ferrum, right? Copper, aluminium, nickel, and titanium. So these are the popular member for this module. You will see them most of the time, right? Then you will mix them together. It becomes something else. It becomes alloy. It becomes alloy. ALLOY. Become alloy. So each member is called element. This is element 1, element 2, element 3, element 4, element 5. When you mix them together, they become something called alloy. It can be metallic alloy. It can be non-metallic. There's no metallic alloy. Only metal alloy. Okay. Then in your chemistry class, you also learn about what is the number on the top, what is the number at below. Okay. So we start to introduce a little bit lah. Just recall back. So what are the non-organic substance that is non-metallic? So carbon, nitrogen, and oxygen. These are the another side of the element. So just now I introduced you the 5 popular member of metallic element, and another one is non-metallic element. So these 5 plus these 3, they can be switch each other to become something else. They become composite, they become uh, ceramic, and so on. Okay. So we have non-metal, metal. Right. Now we start to look into metal because most of the element that we study in this module will be metal, will be metallic materials. Okay. So we start to introduce you one word called crystalline structure. Crystalline structure. It means when you look into microscopic dimension, it repeating the structure. All right. For example, if the structure is cube or in diamond shape, I say lah, right. So I'm not very good in drawing diamond. Right. Okay. So if it's a crystalline structure, it means the shape is repeating many times. So for example, glass, car glass. If anything happened to the glass, or for example, car accidents, you will see that the glass break at a certain pattern. Right? Why the pattern is there is because the way the materials separate themselves in the dimension of microstructure. Okay, so the word crystalline, you will see this word appeared in the question, mention crystalline something, draw crystalline something, or what's something related about crystalline. Crystalline structure means the atoms are arranged in an orderly manner. So when they are arranged orderly manner, means the pattern is repeating, means you don't need to draw the whole object. For example, metal. You study about ion, right? You don't need to draw the whole. Of course, in one of the chapter called mechanical properties, so you don't need to study the whole theorem, but you can break into micro, from macro into micro. Means from the one that you can see, you can measure, into the one that is a very small element inside there. So this one element, it will repeat itself many times. This is called crystalline structures. All right. So in this one only appeared in metallic material, and you learn in chemistry element called polymer. This one also have the same principle. However, the way they arrange is a bit different. The way metal arrange themselves and the way polymer arrange is a bit different. So in chemistry, you learn about bonding, right? Chemical bonding, covalent bonding, second bond, single bond, and all this. Okay, so first technical word for today is crystalline structure. What is crystalline structures? It means the atoms are arranged in orderly manner or repeated manner. So metals, general, they are good thermal conductor and electrical conductor. This one you know. So the rest you read. So in general, metal can further split into 2 classes, metal and alloy. Metals means the 5 popular member, for example, ferrum, aluminium. Then you mix the member together to become alloy. So metal and alloy, they can split into another class called ferrous metals and non-ferrous metals. Ferrous metal means you have this member, Fe member, in the composition. if you don't see ferrum inside the composition, then it becomes non-ferrous alloy or metals. Okay. Yeah. So non-ferrous metal, for example, aluminium, copper, zinc, titanium, and so on. So these are the general idea, right? Okay. So these are the example of application of material. For example, aircraft component. Each component have their own operation, temperature, and all this. So, so including the gas turbine and all this. So this one is you're traveling a lot with inside the Airbus or Boeing, right? So you have this fan. This fan alone will cost you one car price. This blade, one blade, will cost you the price of one a normal saloon car. Then in general view, we haven't go into deep into what is polymeric material. Polymeric material, basically they are polymer that you learn in your chemistry class. So they are consist of long molecule chain, means they repeated with the molecule chain. And polymer, they are non-crystalline. They're non-crystalline. Right. Yeah, so these are the general properties lah. Low density, low decomposition means they easily melt like plastics. So if you have a flame, high temperature, the plastic will melt. The rest you read lah. We'll come to this in the respective chapter. Okay, so this one you learn about this one in your chemistry class also at secondary level. You learn about this one is hydrocarbon, ethylene, C and H, combination of C and H. For example, this one is polyethylene. Poly means many. Poly means many. Ethylene, you combine. This word means there is a repeated of this ethylene or this mer. We call it mer or monomer. This is called monomer. Mono means one. Mer means unit. Right. So, right. So this one you learn about. We'll go into this one in the specific chapter called polymer, which is will be in your test 2 or final exam question, maybe question 4, maybe. Okay. All right. So this is periodic table again. As you can see, it's a bit different from the previous one. The highlighted color is a bit different. All right. So the one that I highlight here, they are non-metallic element. Just now you have metallic and non-metallic. So the one that highlight, for example, hydrogen, carbon, nitrogen, oxygen, ferrum, silicon or silica, they are non-metallic element. For example, so these are the application of polymer, plastics. I think nowadays, young generation, they don't know what is this anymore. And this CD or DVD, right? Rubber and so on. Okay, so again, you'll see this name again in the polymer chapter. So at the moment, you can just understand polymer, example of polymer like plastics. Plastics or PE, polyethylene, PVC, carbon, and so on. Okay, so this one is just some information about plastics. This one you read for information, right? Since you're in Malaysia, we need to give you some information about our country. So the data I pull from Malaysia Rubber Council. As you can see how we use our rubber products in Malaysia or how we export rubber in Malaysia. Okay, so we have a synthetic rubber, natural rubber, and so on. So the growth is increasing every year from 2018 and so on. It's keep on increasing. right? So for example, commercial products, phones, casing, all these things, a lot of more and more synthetic rubber is introduced into the design, including cars, all right? So this you read. So this is our report for Malaysia, right? So this is quite a lot. This one is in billion. So this one is in billion, 2 billion in last year. Last year, it's about 2 billion transaction. It's quite a lot, right? So things, some brand linked with the rubber in Malaysia, for example, Top Glove. During pandemic times, uh, uh, Top Glove make a lot of money because of the use of pharmaceuticals, glove, and so on. This. Okay. All this you read, Okay, now we are done with the polymer or polymeric material. We go into ceramic introduction a little bit. Now, what is ceramic? It's inorganic material. They are chemically bond together. The rest you read. So this is crystallines. For example, how we draw crystallines pattern, right? So it means something that repeated, something like this. So we got the black dot and the blank dot. In this case, in the ceramic material, we use solid black as metals, non-metals as open circle. So those are black one is metals, and so on. Okay. This is just an illustration of what is crystalline mean. What is crystalline mean? As you read. Okay. So as you can compare left and right, the one on the left is crystalline. So if you cannot find a pattern of repeating one, then it becomes non-crystalline. Although it looks same, it looks same. But the way of the arrangement, you cannot describe a certain patterns, right? Then it becomes non-crystalline. Okay. Okay, so there's a video you watch at your free time. So this one is about fiberglass, how fiberglass form. So this one you watch, watch at your free time. Okay. This one also you read. Important is ceramic have two further classification, traditional and advanced engineering. So nowadays we are in this era where most of the time traditional ceramic will be for the tourism industry or for the traditional cultural things, right? Or they use it for a very simple operation, for example, vase or container. Some of these ceramic also, they because of their properties, they can be a good insulator and conductor, depending on the way you design it, right? So advanced engineering means you incorporate or you put inside a lot of technology inside there. So again, you see this periodic table again with a different location of colors. So the light colors one, light and heavy blue. So the one that you see, the light blue is a metallic or metal, and non-metals is here, including the hydrogen. Hydrogen is a very special element. It can become metal, it can become non-metals. Right? So it have a very special properties, right? And nowadays, Malaysia, we're actually developing hydrogen technologies. There's a very huge industry in Sarawak, if you haven't aware, right? So currently, Petronas, they are in the way of getting sustainable solution, beside focusing on the very traditional gasoline industry or oil and gas industry, right? So this is a trend. And if you're traveling overseas, for example, if you go to China, you'll see a lot of EV cars on the road. That is a trend, incoming trend. Rest you read. Advantages, this one you read lah. What are advantages of ceramic? What is different between traditional, advanced, traditional? This one. Okay. So ceramic, they use a lot of in engine, especially when deal with the thermal properties, things that deal with the heat transfer and all this. And even electronics circuit, you use ceramics for the operation. Okay, this one you read, lots of parts that use ceramics. Okay. This one also you watch during your free time. It just tell you that how we use the latest advanced ceramic materials in aircraft engine. This one is in turbine. This one 8 minutes, quite long, so you watch this video at your free time. All right. Just now we are in ceramic. Now we go into composite. Composite means you use 2 or more material integrate together. This is material. Don't use the wrong word. For example, don't use element here. If you use 2 and more element in describing composite, then wrong already. It become alloy. If you use element or metallic element, it become alloy. If you use material, then it become composite. So be careful on the word they use. If the question, for example, question 1, section A, usually is the theory part, ask you about theory, ask about some definition of something. Maybe 5 marks for that definition. Okay. The rest you read. The rest you read. Okay. Now there is also specific chapter for composite. This is just an introduction. So when you come to composite chapter, you'll learn how to form composite. Basically, composite consists of 2 main things only, which is the matrix or the resin, or you can say the liquid that bond the things together. We call matrix, plus the fiber or reinforcement element. Okay, only 2 things only for composite. Matrix plus fiber equal to composite. Then there are some calculation when we go deep into composite chapter. We give you the properties of the composite, means customer say, I want a certain mechanical properties. You mix how many percent of matrix plus how many percent of fiber to get that customer's products. So this will go deep into this. Today, this slide is just an introduction of what you're going to learn in future. Okay, this one also you read. What is matrix? It just further explain what is matrix and all this. Okay. Okay. This is just the information. I won't ask you this kind of very simple question. This is just for information that at least you go to work or you heard before what is matrix composite. Okay. Matrix, ceramic, polymer. It depends on the element inside the things. Okay, the rest you read. This is also application of what are the parts that use composite in aircraft. Right. This one you read lah. For cars also, right? Difference of materials used. Fiberglass, for example, is a composite. right? This under microscopic scale. Microscopic scale. Semiconductor, this one is in your last chapter that we learn about electric properties or electrical semiconductor. Then this chapter we see if we have time, then we go into electrical semiconductor. Then if no, then I'll give you as information to read. So this one also same. Semiconductor is the one that using the element highlight in this diagram. When you read, okay, this is the current trend. Why we need to learn about all these things because of the smart materials for the sensor and actuator, smart robots, um, medical surgeries, and so all this. So what is the word sensors? What is the word of actuator? Sensors means able to detect something. Sensors is to detect something. Actuator is to perform some action of specific function. Okay. So this is a blood vessels on a smart material. So again, this video you can watch at your free times. So this is just to expose you what are the current trend. If you're good in engineering materials, there's a future for you lah. Fuel cell or the battery pack for the EV cars also part of the engineering materials discipline. Okay, so these are the technologies that we have. This one is at micro size scale, a micro electromechanical system (MEM). This system is quite normal in electronic devices nowadays. Your smartwatch, your phone, the way they behave, how your phone know that it's tilted, all these things. The small gyro sensor inside there was made from MEM. Okay. We don't have the equipment to fabricate it, but we have the equipment in the industry. For example, if you are like for example your laptops, your processors, your chips, and all this, then you will see all these things. Then you have a few level. This is just I think this is a very old tech, 10 years ago technologies. Nowadays they go for maybe level 8, level 9 level, means layer. Okay, so this is the MEMs in automotive sensors, smart cars. Nowadays, if you buy a new cars, it comes with the sensors, traffic avoidance systems, and all this. Auto cruise systems that introduced maybe 10 years ago. So all the sensors, they are actually using smart materials that fall under engineering materials dimension. Nanomaterials is very small scale. The word nano means is a size less than 10 power negative 9 meter. Okay. So in this module, we will study at micro scale. So then we go into atomic scale. Later, chapter 2, we will start with atomic scale, learn about crystal structures. Then we will jump to a human scale. We learn about mechanical properties, then go for your test 1. Then after your test 1, we go into this region. We will jump between micro scale and micron scale. Okay, this one you read. This one you read. So this module, sometimes you will see image like this. This is called microscopic image. You look under microscope. Okay, so this is just an illustration of mechanical properties, which is important when you study for the rest of the chapter. So there are a few graphs that you need to aware. So when you plot graph, there is an axis on the left and at the bottom. This is just an illustration, very general, simplified graph. So if you want to compare density, we have learned 4 types of material since this morning, since yesterday, our previous class: metal, ceramic, polymer, and composite. So if you talk about density, metal will always the highest compared to composite. Okay, polymer will be roughly near to composite. Ceramic will be a bit higher than polymer, but lower than metals. Okay. Yeah. So don't confuse with all these very general ideas when it comes to selection of materials. So one is density. So the rest you read. So read. So this one is very direct. Okay, the next slide is about stiffness. Stiffness or elastic modulus. Elastic modulus. Some of you just started to take statistics. Have you seen this equation? Stress equal to modulus Young and strain? Not yet, right? Not yet see this one. Okay, we'll learn this one in mechanical properties. Okay, so stiffness means, is it more easier to pull or deform or not? So metals is a bit easier to in terms of stiffness. Or we call it what? Stiffness, or if we use the word elastic, means when you pull it, you let go, it's able to go back its original shape or length. Stiffness or deformability of that element. So metal, ceramic, composite, they are roughly there, but however, polymer cannot. Like for example, you pull plastics, you pull, then that's it. As you read. So the second graph is about stiffness. The third graph is about strength. Strength means if you press it, what are the force that it can handle? So metals and composite is about there. The lowest one is polymer, or you can imagine plastic. You press plastic, plastic deform. Right? Okay, so these are a bit rough ideas about strength. All the rest you read. Then resistant to fracture. Resistant to fracture means you see there's a break. If you pull it or you compress it, you see crack coming out. So metals can handle it's quite high in resistance. Composite, the second one, ceramic and polymer, roughly same. Okay. We learn a lot about this when it comes to mechanical properties. It's just rough ideas about materials. So you metal, ceramic, polymers, silicon. This one is electrical conductivities. So you see metal very high, followed by semicon, then ceramic and polymer, because of the electron, how the electron was transferred inside there. Right? This one also you read. Okay. Okay. Now, how this information can be asked in test 1, for example. You won't see this one in final exam. For example, test 1, maybe in question 1, section A, it will ask you, I'll just give you an empty graph, something like this. I pick, you have seen like 4 or 5 graph here. Maybe I pick this one, electrical conductivities. Then I ask you to draw where does the region for the 4 type of materials: metal, ceramic, polymer, semicon. You draw something like this. You don't need to remember the scale here, but what is important is you know the region of the materials. Okay. So for example, test 1, question 1, just give you some free marks for, let's say, 5 marks to draw this one. So you will see an empty blank of this graph. Then I put on the left or right, I put electrical conductivity here. Then I ask you to put the region for 4 type material: metal, ceramic, polymer, semicon. So if you draw it wrongly, let's say this graph, the correct answer is this one, you draw another graph, then it's wrong. Okay. The rest you read. Rest you read. Okay. So selecting material, this one is, for example, carbonate barrage container, right? So these are the things that we need to consider when you design for the container. So first, you know that in all these carbonate barrage, inside there you are using CO2, right? And inside there they have a pressure there. So you need to consider what CO2 can do to the materials, what pressure can do to the material when you do design. Then the beverage, the container that you use cannot be toxic, it cannot be reactive. So these are the things that you will see in exam. The customer will tell you all these things, of course, with some value inside the statement. For example, I give you some pressure or what and what. Then you solve the question by doing selection of materials, right? Then relatively strong, when it's dropped from high ground, means mechanical properties must meet a certain criteria. It must be inexpensive. So in this cost also, you need to consider the costing on economic dimension. If can, they should able to have an optical transparent, or people should able to see what is inside. So this is something like that. So this is just some example. So it can be a can, aluminum can, then it's a different design. All right. So the rest so these the things. So the question before we end first half session is that by giving all these criteria, what are the question that you need to think about is what material suitable for this application. So we have learned about metal, ceramic, and polymer, right? So it depends on the application. It's able either this one or this one. It depends. So what are the pros and cons you need to consider when you're answering the question? And then when you answer pro and cons in engineering module, support your answer with a value. Means you support answer with some value that you extract from the chart, extract from the table. So the answer for this one is, if you want to design for a can, then you use aluminum alloy. It can fit all these things. Because aluminum alloy, it can it have a very low diffusion of CO2, because you know that CO2 can come out from inside to outside through the thin wall of the plastics or any materials. So aluminum alloy, it still can release the CO2, but very, very slow. Then it is easily recycled and so on. These are the example. Okay, so when you go into process chapter or processing chapter, we will study this cycle. Design, material, and processing. So this one is one chapter itself, mechanical properties. Design, this one, not inside this module. Not inside this module. However, this design will link with these mechanical properties. Processing, this one, there's also one chapter, part of the chapter when you talk about mechanical properties. Okay, this one you read. So this is how, the rest is just an introduction, how we put inside the content according to the processing, structure, properties, and performance. There are lots of chapter that we go through. The things that you see on the screen here, for example, diffusion, recrystallization, crystal structures, and all this you learn from time to time. Okay. So I highlight all this, what chapter you're going to study this one. Okay, this slide is helpful when it comes to final exam. This chart, at least you know, okay, what have I studied for the past 14 weeks. This chart is for your revision. At least you know, it's a map for you to ask yourself what area you are weak or anything that you miss out. The rest is the same. Okay. This also same. This one you read, so this one also same. So it's a very big chapter. And these are the questions that you can think about for the first chapter. This, if you want, you can do, and then you can think about it. Right? So these are the questions you can think about. Right? You go home and think this one. Okay, with this we conclude chapter 1. Conclude chapter 1. We have a short break. Maybe we continue. How long you need? 5 minutes? 10 minutes? 10 minutes. Yeah, we continue 8:55 8:55 we continue the session. Ten minutes break.